Hey, it's Coach Latham again. This is your SOL math coach, and today we're going to talk about the logic that's on the geometry SOL, and of course we're going to do it in under 15 minutes. If-then statements, this is what they were called back when I was in school. If-then statements are called conditional statements. A conditional statement is where the first part kind of gets you to the second part. We've got some examples down here. It says, if you study, if, there's the if part, you study, then you will get better grades. Kind of like a cause and effect thing. The second one is, if you wash hands often, then you are less likely to get the flu. And then the third one down here, we kind of got it covered up, is if you walk in the rain, then your shoes will squeak. So these are three examples of conditional statements. All right, I've got the conditional statements rewritten here, but I have them written in different colors because I want to point out the two parts of a conditional statement. The if part, the part that comes right after if, is called the hypothesis. That's what we're calling the cause here. And then the then part, the part that comes after then, is called the conclusion. Now the hypothesis, the letter that stands for that is P, and the conclusion is Q. So we get back here, we go, if you study is the hypothesis, then you will get good grades. You will get good grades is the conclusion. Again, if you study is the hypothesis, you'll get good grades is the conclusion. And the second one, if you wash your hands often, that's the hypothesis. And then you are less likely to get the flu is the conclusion. So you can see the relationship between the hypothesis and the conclusion. We call this P then Q for a conditional statement. The little arrow here means then. So it means that if P happens, then Q happens. If you study, then you will get better grades. Now there's different ways that you can switch around these conditional statements. Your base conditional statement is P then Q, and then you've got to remember three different things you can do to that. The first one is the converse of a conditional statement. Now the converse you can remember because the two first letters in converse are CO, and you can kind of think of CO as meaning change order. The converse of a conditional statement is where instead of doing P then Q, you do Q then P, so you change the order of it. So instead of saying if you study then you'll get better grades, you say if you got better grades. And don't get caught up on the English in this. We can go through and change tenses and all that kind of stuff. Then you studied. So you just flip the order. So if you get better grades, then you studied. All right? So that's what a converse is. It's where you take the hypothesis and you put it in the place of the conclusion, and you put the conclusion and you put it in the way of the hypothesis. All right, the inverse. The hypothesis and the conclusion stay in the same order, except it says not P, then not Q. This little squiggly line like that is the negation. That means you're doing the opposite. So for this one, it would be if you don't study. So we'll say if, and then we'll just put a don't in here. If you don't study, then, and then it's also the negation of Q, you will not get better grades. So that's the inverse. The inverse is not. And then the contrapositive is where you put the converse and the inverse together. Not only do you change the order of the hypothesis and the conclusion, but you also negate both of them. So it's kind of like the first two put together. So we're going to switch this, so you will get better grades. Now it goes to the beginning, but instead of you will get better grades, it's you will not get better grades. So if you don't get better grades, then it's going to be you didn't study. And we'll put a did not study right here. And so that's how you figure out the converse, the inverse, and the contrapositive. Again, the converse changes the order. The inverse is not, and the contrapositive does both of those. You change the order and you not. Here's some symbols given. This is the way a problem looked on the SOL test a couple years ago. It says given you fall, P is the hypothesis, P equals you fall, and Q equals you get up. So just treat it like P and you fall are exactly the same thing, so we're just going to translate from one language to another. It says represent the following symbolically. Okay, so it says you get up. That comes first in this statement, so that's Q. So you say Q, then, and then the second part of this statement says you fall, and remember you fall was P, so representing this statement symbolically is Q then P. Let's do the next one. If you do not fall, so we're looking for do not fall. Well, you fall is P, so do not fall is not P. And then the second half, you will not get up. Well, you'll get up is Q, so it's not Q. Not P, then not Q. And then the bottom one, if you don't get up, so we need a not and get up, that's not Q, then you never fell. So that's not falling, so that's not P. So this is these are three examples of how you would translate statements into the symbols. All right, there's always a Venn diagram or two on the SOL test. I've got one here that talks about shot putters, discus throwers, and hammer throwers. Those numbers that are in the sections do not represent actual number of kids. Those are numbers that represent that section. In other words, I just labeled them section 1, section 2, section 3, and so on. And the question at the bottom here, if we can see it on the screen, is which section of the Venn diagram represents athletes that only throw the discus and the hammer? Now, only throw the discus and the hammer means that they throw the discus and the hammer and nothing else. So this is our hammer circle right here. This is our discus circle right here. We're looking for the overlap section of those two where there's no other implement involved. So we're talking about this area right here. So the answer would be section 6. It's not section 5 because in section 5, those guys throw the discus, the hammer, and the shot. And it said only the discus and the hammer. We got a couple more questions based on the same Venn diagram here. It says, which section represents athletes that only throw the shot? So the kids that throw the shot and nothing else. Well, this is our entire shot put circle right here. These sections over here are where there's overlap with other implements, and this one as well, which means that the section where the only one that they do as a shot put is section 1. And then the bottom question, if you can see that, it says, which section represents athletes that throw all 3 implements? The ones that are throwing all 3 implements are going to be the ones right here in this middle section, section 5, because that's the only one that's a part of the discus circle, a part of the shot put circle, and a part of the hammer circle. So anybody in section 5 throws all three implements. The law of detachment is one of the two laws of logic that you're supposed to know in geometry, and I like to call it the law of duh, because this one, you really don't even need to know a name for it to make sense. The definition of it from your geometry textbook is up at the top of the board, but what I like to think of it to make it easy for me is that they give you a general statement and then they give you a specific example. So down here, we've got a general statement. It says, if you put your hand in the fire, then it will hurt. Okay, that makes pretty much sense. It's not a good idea to go around putting your hand in the fire. And then it says, John puts his hand in the fire. And what can you conclude? John's hand will hurt. That's the conclusion. John's hand will hurt or hurts. Again, I'm not an English teacher, but you'll find the right answer if it's a multiple choice question. This is a general statement. Anybody that puts their hand in the fire, then it hurts. John put his hand in the fire, so John's hand hurts. That's the law of detachment. The second law that you're supposed to know is the law of syllogism. And this is the one that connects two statements together. P then Q, Q then R, then P then R is a valid statement. It's probably easier to understand just by looking at an example. It says, if a number ends in 0, then it's divisible by 10. If a number is divisible by 10, then it's divisible by 5. Since the beginning of your second statement matches the end of your first statement, it connects the very beginning to the very end. So your conclusion would be, if a number ends in 0, then it's divisible by 5. And this is the law of syllogism. If a number is divisible by 0, comma, or I'm sorry, if a number ends in 0, if a number ends in 0, then it is divisible by 5. So that would be your conclusion based on the law of syllogism. And that's it. That's really all the topics that you need to know for the geometry logic section. More importantly, it's all of them that we can cover in 15 minutes or less. Thanks. Have a great day.